AP Calculus AB, Unit 6, Day 11, Office Hours. These are the answers to the multiple choice questions at the top there, with a few non-multiple choice questions at the end. I believe I uploaded these for you guys to check online before this, but here they are again. Pause the video if you need to check those, and then I will be going through the whole assignments. Okay, so assuming you guys have checked your answers and you've tried all these problems, let's try it out. Now, multiple choice does not mean less work. In fact, it often means more work than non-multiple choice because sometimes the answers that you get, that would be totally fine on free response, don't quite match up the way they have the answers, so then you have to manipulate them. So, and multiple choice also means they're trying to trick you. So the graph of this function has a relative maximum where. So we're looking for relative maxes. We don't have to, the nice thing about multiple choice is you don't have to justify your answers, but you gotta do most of the work. Y prime equals 6x minus 3x squared equals 0 undefined. Y prime equals, now I'm wanting to see your guys' work. Let's see, so 3x would be 2 minus x. So x equals 0 and 2 are your critical points. So we're going to do a line check. 0, 2, test a point. X equals 3 is going to be negative, positive, negative. Right? So decreasing, increasing, decreasing, relative min, relative max, lots of good stuff. So we're looking for relative maximum specifically. So the relative max is at 2. We don't know the y value. You would have to plug it in. That would be the relative max value. But, I mean, by process of elimination, I think it's going to be this one, right? We can verify. So there are some ways if you're in a hurry. So the point is 2, 4. Okay. Number 2, if, let's see. This fraction, how many zeros does f prime have? Not zeros does f have. How many zeros does f prime have? So we got to find f prime first, which would be e to the sine x, derivative of e is itself. And then you got to do chain rule times derivative of what's inside. And then we want to set this equal to 0. How many zeros does that have? So cosine could equal 0. E to the sine x is never going to equal 0. And you can't take a base and raise it to an exponent, so I'm not get 0. So this is our plan here. X equals 0 at pi over 2 plus pi k. So x equals pi over 2 and 3 pi over 2. So those are the zeros, so there are 2 of them. Okay, 2 of them. All right, 3, you have a function, has an inflection point, then what would the value of k be? So we've been told that we have no inflection point, so we should probably try and find it. So we're going to take the derivative. Now k is just a number. Now this would be the same thing as kx to negative 1, so it'd be negative kx and negative 2. And then we want to find the second derivative, because it's going to get out of equal 0 undefined. So this would be 4, and this would be plus 2kx and negative 3. So we have 4 plus 2k over x cubed equals 0 undefined. So let's see. We should probably solve this. We could give the least common denominator, which is a lot of times what we like to do with rational equations. So x equals 0, but then this is the one that has k in it, so that's got to equal 0. So we're looking for the value of k. Now we know what the x value is. So what we could do is we could plug negative 1 in there for the x value. and then solve for k. So that's going to be negative 4, so 2k equals 4, so k equals 2. K equals 2. Little creative approach using stuff we know how to do. For values of x is graph concave downward. So we got to find the second derivative. So y prime equals, we do quotient rule, low d high minus high d low all over low squared. That term goes away. So we get 2 over 4 minus x squared. Now, we could have done this from the beginning. We could have changed this to, we could change it to this. And then you don't have to do quotient rule like this. We could have wrote it like this, and then we would have been able to just do a simple power rule, right? And you would have got that. Well, yeah, because you still have to do that. You got to watch out for the chain rule. In fact, I think I may. No, I'm good. So if you do the second derivative, it's going to be negative 4, 4 minus x to negative 3. The thing that you got to watch out for is that the derivative of the inside has another negative 1. You got to do a chain rule. So y double prime equals 4 over 4 minus x cubed. And we want to set it equals 0 and define inflection points. So x equals 4. And we do a line check. So we just have 4 on there. It's a repeated root, but 3 times, so that's okay. We can test the value. X equals 0 maybe would be positive, negative, concave up, concave down. Inflection point. So concave down would be 4 to positive infinity. 4 to positive infinity, or x is greater than 4. So used to interval notation that feels weird to pick an inequality like that. Okay. Number 5, for what values of f, what are all the values of x for which the graph is concave down? So same kind of thing. Now you might want to think of this as 6x and negative 1. So then y prime is 12x plus 1/2, derivative 3 is 0, minus 6x and negative 2. And then the second derivative is going to be 12 plus 12x, then negative 3. So that's going to be the same thing as 12 plus 12 over x cubed equal to 0, undefined. You could factor that. You could say, all right, y double prime, let's factor 12. I don't think I'm going to do it. So 12x cubed plus 12. I'm going to put that. So x equals 0. And then x cubed equals negative 1. So x equals negative 1. So line check, should put negative 1 on it, 0, test the value, x equals 1, positive, negative, positive, concave up, concave down, concave up. So we want concave down, negative 1 to 0, negative 1 to 0. Okay. All right. Number 6, the maximum. Now, if it doesn't say relative, that means absolute. So we should probably try to do EVT. These are endpoints. Let's find critical points. 6x squared minus 18x plus 12 equals 0 undefined. Factor it. Take a 6 out. Make life a little easier. X minus 1, x minus 2. So it'll work. Critical points, x equals 1, x equals 2. Okay. Do a line check. Label it. 1, 2, test the value. Oh, wait. What am I doing? Not doing line check. EVT. So our endpoint, so we got negative 1, 1, and 2. And plug these back into the original equation. So if we plug -1 in here, we get -2 -9, -12, -1, -11, -23, -24. Plug 1 in, you get 2 -9 plus 12 -1, -7, 5, you get 4. Plug 2 in, you get 16 -36 plus 24 -1. It's going to be -24. It's going to be 3. So this is your mat, or that's negative. So this is your max. That's your min. Now, they want the max value. So that's the y value. So this is what we're going for, the 4, not the location, but the actual max y value. There we go. Number 7, for all values of x, f prime is negative, f double prime is positive. So it's decreasing the whole time, and it's concave up the whole time. Whereas falling curves could be part of the graph. So it's got to be going down the whole time. Nope, nope, nope. It's got to, only these two are going down the whole time. It's got to be concave up the whole time. This one's concave up, and then it's concave down. So there you go. Quick problem there. Okay, number 8. What values of x does the graph have relative minimum? So let's do f prime of x equals 4x cubed minus 16x. Set factor, set equals 0 undefined. So we're going to take a 4x out. We're going to have x squared minus 4 equals 0 undefined. X equals 0, x equals 2, x equals -2, right? X plus 2, x minus 2 if you want to factor it or solve it. So those are your critical points. So we do a line check, -2, 0, 2, label your line check, test the value, tell me what you test, x equals 3, positive, negative, decreasing, increasing, decreasing, increasing, decreasing, increasing, decreasing, increasing. This is a relative min right here, relative max right there, relative min right here. It says, what are the values of x? We have a relative min, so that's this guy and this guy, -2 and 2 only. All right, number 9, the function has horizontal tangent and a point inflection, the same value of x. What must the value be? It must be the value b. So inflection point and horizontal tangent. So if we do y prime, we get 4x cubed plus 2bx plus 8. And if it's horizontal tangent, it means it equals 0. So that's one relationship. And then y double prime equals 12x squared plus 2b. And if it's inflection point, it probably means it's equal to 0. So we have a system of equations. And we're looking for the value of x. No, we're looking for the value of b. But it might be easier to find the value of x first. Like to me, this stands out. I want to replace this 2b with what this one's with. So 2b right here equals -12x squared. I'm going to plug that in up here, and then I'll have pure x's. I can find the x. When I have the x, I come back up here and find b. So 4x cubed plus, if I plug that in, I'm going to get -12, 20. So I'm replacing 2b with this. So it's going to be -12x cubed plus 8. And so then we get -8x cubed plus 8. So we get 8x cubed equals 8. So we get x cubed equals 1. So x equals 1. So then I can plug that back in up here. 2b equals -12 times 1 squared. So b equals -2. -6. System of equations. Got to be able to solve system of equations. Okay. 10. What are the values of x for which the graph is concave down? First derivative, 3x squared minus 12x. Second derivative, 6x minus 12 equals 0 undefined. These problems should be like 2 minutes or less on the AP test. X equals 2, line check, test the value, x equals 3. In the second derivative is positive, negative, concave down, concave up. Inflection point. We want concave down, negative infinity to 2, right? Or x is less than 2. All right, number 11. In which interval is the function increasing? So that's where f prime is positive. So f prime equals 3x squared plus 12x plus 9. And then we're going to factor it. 3x squared plus 4x plus 3. Keep going. X plus 3, x plus 1. X equals negative 3, negative 1. So those are your critical points. So I'm going to do a line check. Test x equals 0, positive, negative, positive, increasing, decreasing, increasing, increasing, decreasing, increasing. We want increasing, so this and this. So negative infinity, negative 3, and we include the endpoints, and negative 1 and positive infinity. Negative infinity, negative 3, negative 1 infinity. So I think it's this one, D. Now you might be like, oh, but those have parentheses. That's fine. They're not going to try and trick you on purpose. So this just happens. You know, they're not going to have both of them make you choose. So you should feel all right with that. 12 says if you have this function, then what's the point of inflection? Well, we got to take the first derivative. We got to do product rule. 2x times e to the negative x is e to the negative x. Times derivative of what's inside is negative 1 plus e to the negative x times derivative of 2x is 2. We go start factoring a 2x to the negative ex out. It's going to be a negative x plus 1 left over equals 0 undefined. So x equals 1 is your critical point. And we don't even need that. I shouldn't have bothered. Second derivative. Negative 2x times derivative e to the negative x is e to the negative x times derivative of what's inside is another negative 1 plus e to the negative x times derivative of negative 2x is negative 2 plus 2e to the negative x times derivative of what's inside is negative 1. This is one we should be factoring. But we might be able to combine some terms. I mean, I'm going to try and clean this up first. 2x e to the negative x, and then that's going to be minus 3e and minus 4. Minus 2, minus 2, minus 4e to the negative x equals 0 undefined. And so we can factor out a 2e to the negative x. We'll have an x left over, minus 2. And x equals 2 should be an inflection point because it's not an even root, it's not even repeated. So that should be the inflection point. I mean, you could do a line check to show where it is, but 3, positive, negative, concave down, concave up. But I don't think you really have to do this. Inflection point at x equals 2. All right. Next on the graph of the derivative, this is the graph of the derivative as shown above, which of the following could be the graph. Okay, so we got it. I would start interpreting this like f prime is negative, so it's decreasing. F prime is positive, so it's increasing. F prime is positive, so it's increasing. So the graph should go down, up, flatten out, and go up more. Down, up, up. The only one that looks like that is this. That's it. It's going down, then up, then up. All right. This one goes down, up, then down. This one's going up, right? And then down later. This one's going down, then up, but it doesn't kind of have that extra thing. This one's, yeah. So that's it. I mean, you can quickly identify these original graphs. Equation of tangent line to the curve at its point of inflection. So we're trying to find the equation of tangent line to the curve at its inflection point. So we got to find the inflection point first. So y prime equals 3x squared minus 12x. Y double prime equals 6x minus 12 equals 0 undefined. So you could factor it if you want. So x equals 2 should be the inflection point. So we want to find the equation of tangent line. So we have the x value we want. We need the y value that goes with it. So it's going to be 8 minus 24 is negative 16. So that's your point. We need the slope. We have y prime, so we just need to plug 2 into that. So that's going to be 12 minus 24 is negative 12. So that's your slope. So y minus negative 16 would be plus 16 equals negative 12 times x minus 2. So that's the equation in point slope formula. For response, that'd be fine. But now you're at the mercy of these, so you're going to want to change to slope intercept form. Y equals negative 12x plus 24 minus 16. Y equals negative 12x plus 8. Negative 12x plus 8. You have lots of common mistake answers on there. Okay. Well, that was kind of an interesting, challenging problem. Okay, 15. At which of the 3 points of the graph in the figure below will f prime be less than f double prime? Okay. So f prime is 0 here. F prime is 0 here. F prime is positive. F prime is negative. F prime is negative. Looks like f prime might be 0 there. And then we're looking at the second derivative. Here, f double prime is negative the whole time, f double prime is positive the whole time, and then f double prime is negative. Now, I don't think I really need to do this because I should have just looked at points A, B, and C. So point A, the slope is negative, and the graph is concave up. So f double prime is bigger than f prime there. So yes, at point A. At point B, the slope is positive, the second derivative is negative, so the second derivative is not bigger, so not B. C, the slope is 0, and the second derivative is negative, is concave down, so it's not bigger, so C is not, so it's just going to be A only. I think I was about to analyze the whole graph, but it was just certain points that we need to look at. So you just look at the slope and the concavity, and it's usually just one's positive, one's negative, one's 0. It makes it easy to compare them to each other. 16 for what values does have relative min? So we got to find the derivative. 24x to the fifth minus 24x squared equals 0 undefined. So then we need to factor it. So x equals 0, x equals 1. That's going to bounce. Line check, 0, 1. Test the value. X equals 2. Positive, negative, negative. Decreasing, decreasing, increasing. Relative min, neither. So we want the relative min. That's relative min. That is the x value, 1. Okay. 17, what's the minimum? That means absolute. Now, it doesn't give you endpoints. So we can't do EVT. Let's try and do first derivative test and see if it works out. So we got to find the critical points no matter what. E to the x minus 2 equals 0, undefined. E to the x equals 2, natural log of both sides. X equals natural log of 2. That's your critical point. So if we did a line check, let's see what happens. We have one critical point, which is promising. Let me test the value. Now, by the way, the natural log graph looks like this. So here's natural log of 1. Natural log of 2 is definitely positive. If we tested 0, that would be on the left side, which would give you negative, positive, decreasing, increasing. Now, here's the deal. This is a relative min, but would you guys agree that this is the absolute min? Because the graph goes up forever on both sides. I'd say there is no absolute max. This is the absolute min. So now, did they say the location of it or the actual value? They want. So some of you guys are going to pick that. That's wrong because that's the x value. They want it the minimum value, the y value. So we got to plug that back in to here. So that's going to be 2 minus 2 natural log of 2. And that's the closest here. Now, also remember, just keep in mind, this could be 2 natural log of 4. You could bring this in as an exponent. 18, the graph is increasing, decreasing, increasing here, there. Well, let's just figure out what's increasing, decreasing. So we're going to find the derivative. And say equals 0 and define. Factor it if you want. Solve it. Now, this is going to be x equals plus or minus 2i. Imaginary, which means they're not going to show up. But we can still do a line check. There's no critical points. You can still test the value. Just test any value you want, like a 0. And it's positive everywhere, so it's increasing all the time, which is one of your answers. It's increasing for all x. Which of the functions sketched below is increasing at a decreasing rate? So increasing means f prime is positive. Decreasing rate means it's getting smaller and smaller. That would mean that the slope of the slope is negative. So decreasing rate means the second derivative is going to be negative. Okay. So which one is going up? But concave down. Going up, concave down. Going up, concave down. That's it. What is the maximum value of the derivative? Maximum value of the derivative. Well, we got to find the derivative. And then if we're looking for the maximum value of the derivative, then that means critical points for the derivative come from the second derivative. So we're going to set this equals 0 and define. It's a little weird. Maximum value of the derivative. F prime max. Now we can do EVT, but maybe this is just right. Test 2, it's going to be negative, positive. Now, I'm going to think of it this way. Increasing, decreasing. F prime is increasing. F prime is decreasing. This is a relative min of F prime, and it's the absolute max of F prime. That's the x value, so then you got to plug this back into the derivative, which will give you 3. 3 is the maximum derivative, value of the derivative. How many points of inflection does this have? Okay, well, let's find the second derivative. First derivative first, 12x to the fifth plus 45x to the fourth plus 40x to the third minus 1. Second derivative equals 60x to the fourth plus 9180x to the third plus 120x squared equals 0 undefined. Factor it. So we take 60x squared out, and that would leave an x squared plus 3x plus 2 We factored a little more. X plus 2, x plus 1. So these are potential inflection points, 0, -2, and -1. This one, because it's a repeated one, is not going to be, it's not going to change signs. It's not going to change concavity. It's these two. So the answer is 2, not 3. Be careful, right? If you did a line check, not that you have to, but if you did a line check correctly, you test some point, like x equals 1, be positive, it stay positive, negative, positive, concave, up, down, up, up. Here's an inflection point, here's an inflection point. 0 is not an inflection point. For what value of k will this have a relative max? Well, let's see where the relative max would be. F prime of x, low d high minus high, k is just a number, high d low, all over low squared. So this is going to be 8x squared minus 16x squared minus 2kx over x to the fourth. We could clean this up. Negative 8x squared minus 2kx over x to the fourth. We could factor it. Negative 2x out. Be 4x minus k over x to the fourth. So equal, we're trying to find a relative maximum. 0 undefined. So x equals 0, x equals 0. So it's actually going to be like an odd root. And then x equals k over 4. Okay, so for what value k will have relative max? So, I mean, we could even say, oh, okay, let's do a line check. We got 0, k over 4, test a value. You test like -1 or something. Now this is assuming k is positive. See, I don't know. For what value of k will have relative max? At x equals 4. Okay. So let's say, okay, right here, this is going to have to be 0, right? So k has got to be 16. Positive 16. No, it says negative. Shoot. Oh, this should be a plus right here. Interesting. Okay. All right, suppose the derivative of f is shown. This is the graph of the derivative, which the following could be the graph. So one thing you might notice is that the graph is increasing the whole time. So any graph that ever goes down is out, out, out. It's got to be D or E. Now the other thing is that the slope goes towards 0. Slope goes towards 0, so it's going flat on either side. That's this guy. It's going flat. It's going flat. This one's getting steeper. And also that you should have a slope of 1 in the middle, which kind of makes sense there. So that's it. That should be quick. On the A/B test, you're not going to have to sketch a erosion graph, but you should be able to pick one real quick. 24. S is a twice differentiable function on A to B, f prime to C equals 0. C to A to C, which of the following statements must be true? Well, this kind of sounds like extreme value theorem or something, right? Closed interval, derivative. A would have to equal B, like the two edges have to equal each other. No, it They could. F has a relative extremum at C. It's possible, but it's not for sure because it could be like a plateau. Might not be a relative min or max. F has an inflection point at C. No, that's not necessarily true either. So I'm going to say none have to for sure be true, right? I mean, we could have relative max, we could have relative min, but we could have neither, right? There could be an inflection point there. There might not be an inflection point. This one has an inflection point, but these don't. So we're looking for something that has to be true. None of those have to be true. 25, if this is a graph, it says it has a point inflection here, what does the value be? So let's go looking for this inflection point. First derivative, 3x squared plus 2ax plus b. Second derivative equals 6x plus 2a, and it should equal 0 or undefined. And they're telling you it's going to happen at x equals 2, y equals 0. So y double prime at x equals 2 would be 12 equals negative 2a, a equals negative 6. But they're not asking for a, they're asking for b. So then you would plug this back in to that equation, because y prime, well, no, we plug this back into the original equation because we have an xy value. So when x equals 2, and you plug 2 in here, and we found a was negative 6, you plug 2 in, and then it's got to equal 0. They told you what the y value was. So we can solve this one now for b. So this is going to be 8 minus 24 plus 2b minus 8 equals 0. 2b equals 24, b equals 12. B equals 12. So the answer is D. Okay. Number 26, which if this is f prime equals that, which the following could be the graph, Well, it means that we should have critical points at A, B, and C. Peaks, valleys, or plateaus at A, B, or C. A, B, and C. And A is left, B is in the middle, C is. So we should definitely have that. I mean, what we could do is we could start doing a line check. This is kind of interesting. Where we put A, B, C on here, because that's order, size. We could test some value bigger than C would make all of these positive, right? Since C is the biggest. So that'd be positive, negative, positive, negative. So decreasing, increasing, decreasing, increasing. So this gives you a nice view of what the graph should be doing. So we have relative min here, we have relative max here, we have a relative min here. So it should go down, up, down, up. Down, up, down, up. This one kind of seems right. It's got to go down first. So that one's going up first. That one's going up first. That one's going up first. It's got to go up on the end. On the right side, this one's going down. That's the best fit is answer B. A little line check helped. 27, these Roman numeral problems, kind of like 3 and 1. You got to get all 3 right to get the whole thing right. Suppose that f prime and f del prime are continuous for all real numbers and that f has the following properties. F is negative from negative infinity to 6. So f is negative and positive. F prime is increasing on negative infinity to 8. So positive first derivative increasing and decreasing. Okay, f double prime, the concavity, f double prime is concave up on negative infinity to 3, concave down for the rest of the way. Of the following, which is the smallest value? F double prime of 3 probably equals 0. F prime of 10 should be negative. F prime of 4 should be positive. F prime of 1 should be positive. f prime of -7 should be positive. Which one's the smallest? Well, there's only one negative value, so it has to be the smallest. Okay. So you get to use a graphing calculator for these ones, so you should really want to use a graphing calculator, even if you think you can pull it off by hand, because graphing calculators can be quicker, should be more correct. And honestly, sometimes you guys think you can do it by hand, but you can't. So the second derivative of the function, so they give me a second derivative. How many inflection points does it have? Well, let's just graph this. Let's graph the second derivative. So 0.5 plus cosine x, close the cosine x, minus e to the negative x. Now you better be in radian mode. Go to window. We're concerned with 0 to 20. We could say zoom fit, which might take a little longer, but it pre-calculates the y values and resizes the y values to fit in the window, resizes the window. So this is the graph. Let's go and just sketch it real quick, just to help ourselves remember how we did this problem. An AP test, you would just probably answer it, but this is okay. And so this is f double prime. It says how many inflection points? Well, f double prime is going from positive to negative, right? To positive to negative, and so forth. This is inflection point 2, 3, 4, 5, 6 inflection points on 0 to 20. 6. Easy. Quick. Doing that by hand would have been terrible. How many inflection points does this graph have? Well, let's see. How many inflection points does it have? And can we find? We could graph the derivative graph. We could trick our calculator into graphing the derivative graph. So parentheses pi divided by 2 raised to the parentheses x to the third minus 8. And then, maybe we say negative 10 to 10 and negative 10 to 10. And then we go to y equals, and we're going to turn that one off. I want to graph its derivative. So down here, I keep this guy saved, but let's say you got rid of it. You go math 8, you go vars, y vars function, y1, comma x, comma x. So let's see if this will work. It takes a little longer as to calculate a lot of derivative values, but this is going to be the graph of the derivative, which I think we've gotten really good at analyzing the graph of the derivative. It's taking a long time. I mean, this looks like some kind of almost like exponential or something, which it kind of looks like there. I mean, window, -5, 5, maybe -1 to 50. See if we can get a better view of it. Now we're really kind of concerned with the x-intercepts of this derivative graph. There it is. Wow. It really goes down towards that asymptote. So, I mean, quick glance, f prime graph looks something like this. It might be good to see what's going on closer to it. So we could say like window equals, say that. See what's happening really close right here. Kind of what it looks like on a big scale. So there it is. Just go up and then down a little bit. Oh my gosh, this is crazy. I mean, negative 0.1 to 0.1. I'm really zooming in on the x-axis. So there it is. Wow, I mean, it looks like it dips on down under it. What are we answering? How many inflection points? I mean, geez. I mean, here, let's look for x-intercepts. We can say second calc 0. We can say like -5 to -1, guess -2. I'm going to see if there's one around there. If it says error, no sign change, that means it doesn't have any x-intercepts. Everything takes a long time here because we're using that trick. Wow. Okay, so there is no x-intercept there. Is there one there? Second calc 0, -1 to 1, guess 0. See if there's one there. Well, I mean, the graph now closer, it looks like it goes like this, right? If that's f prime, f double prime, this is f double prime is positive, f double prime is negative, f double prime is positive, so there'd be inflection point here and here. So I'm going to go with 2. I feel like doesn't the x-intercepts don't even matter here, but it's kind of tricky. Okay, 30. The f be a function whose derivative is, so the given derivative, how many relative maximums does that? Let's just graph it. So let's go, I'm going to turn this one down off down here. And I'm going to put this in x over 15 plus sine e to the 0.2x, close, window, 0 to 12, zoom, fit. Let's see what happens. Just trying to graph the derivative graph. And from that, we should be pretty good at finding relative max and mins. So it's increasing, now it's decreasing, it's increasing and decreasing. So I'm going to sketch that real quick. So this is the graph of the derivative from 0 to 12. So here f prime is positive, increasing. F prime is negative, decreasing. F prime is positive, increasing. F prime is negative, decreasing. Critical point, critical point, critical point. It's going up and down. This is relative max. It's going down and up. That's a relative min. It's going up and down. That's a relative max. So what are we looking for? Relative maximums. It says how many? I'm going with 2. Now, some people are going to be like, there's a max and there's a max. There's 2. Well, you just got lucky because it happened to coincidentally give you the same number. Okay. Number 31. Which statement is true for the function on the open pi to 5 pi 4? It's increasing at increasing rate. Now, increasing means f prime is positive. Increasing rate means f double prime is positive. Increasing f prime is positive. At decreasing rate means the second derivative is negative. Has an absolute max, has an inflection point, has a point of symmetry. Let's try and graph this. So natural log of tangent x, window is pi to 3 pi over 4. No, 5 pi over 4. And then we could do zoom fit. So trying to get a quick graph. Wow. These look like really big numbers. Kind of looks like that, right? Window, I mean, super big. Y min, how about -10 to 1? So there's the graph. So I would say that it's increasing, but it's concave down, increasing and decreasing rate. I'm going to go B. It doesn't look like it has an absolute max. It doesn't look like it has a point inflection. It doesn't look like it has any kind of symmetry. And it's not concave up. So, 3-2, if the derivative function f is given, so they give you the derivative, how many critical points does it have? Let's graph it. This is a great thing about your graphing calculator. We usually don't rely on graphs, but if it'll graph it, the sine of x to the x and window 0.2 to 2.6. And we could do zoom fit. Let our calculator do the work. So this is the graph of the derivative. All right, so I'm going to sketch that real quick. So it goes like this from 0.2 to 2.6. So it says, how many critical points does it have? Well, that'd be when f prime equals 0. 1, 2, 3. 3. Easy, quick. Okay, 33, that f be a function is continuous on 2 to 10, whose derivative is given by, which the following is true about the interval. Okay, so let's graph this guy. Cosine x divided by natural log of x plus 1, window 2 to 10, zoom fit. I should be getting quick at this. Take a little breather while your calculator does its job. So this is the graph of the derivative. So the graph of the derivative, I'm going to do a quick sketch of it from 2 to 10. Looks like that. So here f prime is negative decreasing, f prime is positive increasing, f prime is negative decreasing, f double prime is positive concave up, no, down, it's negative. Here f double prime is positive concave up, f double prime is negative concave down, and a little bit of f double prime is positive concave up. So we can identify lots of good stuff. Critical points, relative maxes, mins, inflection points. So it says it's monotonic. Monotonic, it's kind of like the vertical line test, but also horizontal line test. Meaning one of the effects of it is a monotonic graph. It's called a one-to-one, means it's going up the whole time. Every x has exactly one y, and every y has exactly one x, which isn't always true. It's going up the whole time or down the whole time. Well, that's not true. This is going down, then up, then down. Has a relative minimum. Well, decreasing, increasing, this is a relative minimum right here. Increasing, decreasing, this is a relative maximum right here. It has a relative max and a min, so it does have relative minimum. Has 3 inflection points. Well, it's going from concave down to up. So there's an inflection point there, and then up to down here, there's an inflection point there, and there's another inflection point here. So I'd say yes, 3 inflection points. So I'm going to go with 2 and 3 only. 2 and 3 only. Okay. Last problems. So this problem deals with functions defined as this. So it's like a cubic in the viewing window provided below, graph the members of the family. So they're telling you, okay, graph x to the third minus plug b equals 1 in, so it's 3x. And then graph x to the third, plug a 2 in, it's going to be minus 6x. And then graph x to the third minus plug a 3 in, that's going to be 9x. So let's window based off this graph is negative 5 to 5, negative 15 to 15. So we do quick. So that's the first one. And then the second one was like a little more pronounced. And then the next one is even more pronounced. So that's just a quick b equals 1, b equals 2, b equals 3. Quick sketch. B, find the x and y coordinates of the relative max points of f in terms of b. So relative maximum. So you want to do f prime of x equals 3x squared minus 3b equals 0 undefined. So if you factor that out, x equals plus or minus the square root of b. That's the x coordinates. The y coordinates, you plug this back into the original equation. And we would get b root b minus 3b root b. That'd be negative 2b root b. That's if you plug in positive b. So positive root b, negative 2b root b. That's the x and y coordinates of that relative max. If you plug in negative root b, we get negative root b cubed minus 3b negative root b. So that's going to be negative b root b plus b root b. Should be a 3 here. So that's going to be positive 2b root b. So the other one's going to be, that one's positive, and this one's going to be negative root b, positive 2b root b. So those are relative maxes and mins. Oh, relative maximums. It's got to be the negative one for sure, right? And the relative mins, that's this one. Relative mins are definitely happening in the positive side. And their y values are definitely negative based off the graph. And D says, show all the values b greater than 0, the relative max min points lie on the function. Points lie on a function of the form y equals negative a x cubed by finding the value of a. So we already found the relative max and min values. Right? It says relative max point lie on this graph. Well, let's see. Show that for all values of b greater than 0. So those are positive b values. So if we plug this in, 2b root b equals negative a negative b cubed, 2b root b equals positive a b root b. Divide both sides that, a equals 2. So yeah, it'll follow that. And then negative 2b root b equals negative a positive root b cubed. So negative 2b root b is negative a b root b. Divide both sides by b root b. A equals 2. So sure, yeah, that would essentially, this is saying that the equation for this one would be y equals negative 2x cubed, and this one would be y equals negative 2x cubed. So these points for sure lie on this cubic graph with a value 2. They weren't specific, and they said find the value of a, so we did. A equals 2. All right, that's it. I guess graphing calculator didn't really come in handy there except for the first step.